In a previous video, we looked at how we could use tree diagrams to list the sample space of all the potential outcomes that could occur. Today, we're going to have a look at a bit of a different use of tree diagrams. To help us do that, I'm going to consider the following problem. Let's say we had two bags that contain different amounts of pink and green marbles. And what we're going to do is to select one marble randomly from one of these two bags. But to determine which bag we're going to select it from, we're first going to flip a coin to work out which bag we would choose. What I want to know is, what is the probability of us getting a green marble from either one of these two bags? Well, to calculate that, what we would need to do is to work out what is the chance of getting bag A followed by a green marble from that, and we would add that to the probability of selecting bag B and then getting a green marble from that. Now, what we've essentially got here is two different kinds of compound probabilities combined together. But what I'm going to show you is how we could use a tree diagram to help us find these two a little bit easier. So in a tree diagram, we begin by listing out what events could occur first. In this case, we're choosing which bag that could occur. And what we could get is either bag A or bag B. So we list out what is the probability of getting bag A. We're flipping a coin for it, so it's a 1 in 2, which also means the probability of getting bag B is a 1 in 2. Then we look at, if we get bag A, what else could we get? Well, we could get pink or green marbles. Now, the probability of getting pink marbles is a 2 in 5. And the probability of getting a green marble is 3 in 5. So then we look at, if we got bag B, what could we get? Well, it's pink or green marbles. Now the probability of getting a pink marble in bag B is 3 in 4. And the probability of getting a green is 1 in 4. So the tree diagram shows us that there are 4 different outcomes that could occur. You could either get bag A and a pink marble. You get bag A and a green marble. You could get bag B and a pink marble. Or you could get bag B and a green marble. But what we're most interested in is bag A in green and bag B in green. So this one here and this one here. So what we now do is we look at what is the probability of getting bag A and a green. To find that, we've got to take the probability of getting A, which was a 1 in 2, and multiply that with the chance of then getting the green marble, which is a 3 in 5. Now that is equal to a 3 in 10 chance. For this one here, the probability of getting bag B was a 1 in 2, and we've got to multiply that with the probability of getting a green there, which is a 1 in 4 chance. So that is equal to a 1 in 8 chance. So now what we've essentially done is we've worked out the individual probabilities of us getting a green. To find though the probability of us getting a green in total, we've got to add the individual probabilities together. So what we've got to do is we've got to take the probability of picking bag A and a green, which is a 3 in 10 chance, and we add it with the probability of getting bag B and a green, which was a 1 in 8 chance. Now to add these together, we need to multiply this side by the 8, so that'll be a 24 in 80, and multiply this side by the 10, which is a 10 in 80. So when we add these together, it will be a 34 in 80, which simplifies down to a 17 in 40 chance. So our probability in getting a green overall from the start is approximately a 17 in 40 chance, which is just under 50%. So to summarise, another use of tree diagrams is to start listing out multi-step events that could occur, and we can actually work out what is the probability of each one of these steps occurring and then calculate compound probabilities from this.